Hey Nick, hope your grading's been going well so far. I'll try to keep this one relatively quick for you. So what we're going to do first today is start with our game. We're going to do a little playthrough, going through 4 sections, each focusing on a different sort of gimmick or transformation. We're going to finish the game first, then we're going to look at the code, talk about how certain decisions were made and why. We're going to talk about things that were hard, things that took a lot of time, and what could have been done better. So starting with our translation puzzle here, we're presented with 3 platforms and 2 boxes. They look the same, but if you turn on the hitbox viewer, you'll notice that these 2 platforms here are static, and the one in the middle is dynamic. These 2 boxes actually act as switches influencing this dynamic platform by applying a force to it. The left box will apply a left force, the right box will apply a right force. So naturally, since we're in a platformer, we're going to try to go to the right and get this platform sliding out. We're going to wait for it, and it's hit something, or it's stopped. So now we're going to roll out on it, and we're going to see that there's this wall here that Link can't get up on his own. You can't. But since this platform actually has no gravity, if we bounce on it a couple times, we can actually use it as a springboard to bring Link a little bit higher and get past this wall. Now on to our next puzzle. We're presented with a switch all the way down here, as this box, and a ball. Now obviously Link can't touch that switch, unlike he could before, so we're going to use the ball and push it onto the switch instead. And you'll notice up here, we had a wall here that got destroyed when the switch was hit, dropping some polygonal boulders that are randomly scaled every time. Now, the reason we made Link a ball here, which you might have noticed already, is because it makes climbing these sort of irregular platforms a lot easier. Now, that was our second translation puzzle. We're going to move on to our first rotation puzzle. So this one's kind of inspired by the twisty sections of Green Hill Zone, you know, like those S's where you go really fast. So what we're going to do is use our R key here to rotate this platform and actually push us all the way down here. He's going to push us, and we can roll down to the next place. Finally, onto our last puzzle. We're presented with this yellow sort of teeter-totter looking polygon, which can be tipped by scaling a small box that is right there. So we're going to use our O key to scale it, and it's slowly going to push our polygon upwards. We've made it a little too big. It's gotten stuck on something. All right, there we go. Now we can climb on it, and now we have it bridged in between this last platform, so we can go on it. And those were our 4 little sections. And that's the basic little demo for my game. So now let's go on to the code. First of all, I wanted to make this code as reusable as possible, so I definitely invested the most of my time into making a lot of helper methods to construct objects quickly. So you'll see here, I have ones that produce a trigger that destroys a target. I have something that produces a dynamic ball, a dynamic platform, a basic platform that's static, and I have some translation triggers as well. And I can create some randomly generated boulders. So what all these methods do is actually return the entity after the method is completed. So it'll make a very basic rendition of what you want. And let's say you wanted to change the gravity on, for example, a translation trigger. Maybe you want it to not be affected by gravity. So we can just assign the entity to something else. We can assign the entity to something like starting platform, and then if we wanted to edit starting platform, we can just get whatever body we need, whether it's the sprite or the physics body, and edit it from there. So this made designing levels relatively small compared to what I think other students were doing, to where my entire first section is just this, and my entire second section is just a couple lines. The only larger sections were ones that had to use custom polygons, such as this seesaw, or the boulder builder that I put up there. So I thought this was a really beneficial method of doing things, and has definitely front-loaded a lot of the work for me. Then in terms of things I found really hard, that was getting my triggers to work properly, specifically that translation trigger. So originally I tried to pass the world to it, and all these different things to brute force applying a force to it, but I had to really go back and look at what physics body exactly does and how to manipulate it, and how this auto keyword works. And once I got that, this one line probably took me like 2 hours to figure out how to do properly. And thanks to some of my friends to help me out, I got it figured out. And yeah, that was probably the biggest hurdle for me, just relearning physics body. And in terms of things I could have done better, I think I definitely wasted a lot of time trying to make concave shapes and wondering what was wrong. So in terms of for example, my seesaw originally looked like this instead of having this more curved out area. But unfortunately, this corner was a concavity and it caused the seesaw not to collide properly with other things. So it took me a while to figure that out and I had to redo the collision on both my polygons actually. My boulders were originally a different shape too. I also could have added visuals, but I thought that since the focus of this assignment was on the physics, it would be better to spend more time working on those methods to make building levels faster, and because I can also use those methods on my GDW, and I thought even if it doesn't look as nice, it working properly is definitely a little more important for me. So overall, I had a lot of fun with this assignment. I think there was definitely some frustrating parts, but I can say that I did learn a lot, and yeah, that's about it. Thanks for watching.